Hi, the title of this plot is the using nanoparticles of boron, copper, manganese, molybdenum, and zinc to suppress Fusarium crown and root rot of asparagus. I'm Wade Elmer, and this plot was done by me and assisted by my technician, Mr. Peter Thield. Fusarium crown rot of asparagus is a fungal disease that occurs wherever asparagus is grown, and it's caused by species of a fungus called Fusarium. There are many different species that can cause this particular disease, and it occurs in the soil, and it is commonly found wherever there's an asparagus planting. The disease symptoms are quite distinct. Usually in older fields, you'll see this lemon yellowing coloration to the fern, which then collapses. If you dig the crown, you'll see rotted roots and a reddish discoloration inside there. There are no cultivars that are highly resistant to this disease, and fungicides are relatively ineffective. Now, we had found that healthy plants had more micronutrients in their roots than diseased plants. So we hypothesized early on that adding micronutrients might suppress this disease. So we did studies where we added the micronutrients boron, copper, manganese, molybdenum, and zinc, and we added them as nanoparticles. Now, why nanoparticles? What is a nanoparticle? How big is a nanoparticle? Well, a nanoparticle is any particle that has a diameter less than 100 nanometers. So anything could technically be a nanoparticle. To give you some idea of the size differentiation, if the Earth was a particle, a soccer ball would be about the size of a nanoparticle. So this is the size differentiation we're using. Nanoparticles are very unique. Because they're so small, they have tremendous surface area. They can also release the metal, the nanoparticles, at a much faster rate. Also, because of their small size, they can travel through tissues much faster than the larger particles or their equivalent salts. We started off looking at nanoparticles by doing split root studies, where we took a very young planting here in the upper left, and we would slowly separate the roots into two sections, and we would allow the roots to grow into two separate pots. So this is called a split root study. And then in the soil, we would have the fungus that causes the disease, but we would only treat one side of the pots with the nanoparticles. And here we used nanoparticles of copper, and these went into side A. Later on, we would look to see what would be the effect on side B. This is a great way to separate the effect of the nanoparticle on the fungus with the effect of the nanoparticle on the plant. In this particular study here, we're looking at the percentage of the diseased roots. So the bigger the bar, the more disease. So you can see in the untreated control, this was a plant that was inoculated but did not receive any nanoparticles. We had almost 50% root rot in that treatment there. When we treated side A, you could see that the amount of disease dropped down to about 18%. But what was more surprising is that on the untreated side, we saw the same level of disease suppression. This suggests that the nanoparticles were not directly affecting the pathogen, but were actually altering the physiology of the plant, making it more resistant. This was very interesting. So we conducted a study where we went out and we soaked crowns of asparagus in nanoparticle solutions. This was set up 2 years ago in 2018. And then yield was collected this year for the first year. And what we have here is the marketable yield per row. These are the number of marketable spears that we would consider to be sellable in the marketplace. And as you can see, all the nanoparticles, boron, copper, manganese, molybdenum, and zinc, did better than the untreated plants. But due to a wide range of variability, statistically, there was no significant difference. However, this was just the first year. We anticipate that in the years to come, we will be able to see these differences get larger and larger, and there will be statistical differences over time. So in conclusion, we think that nanoparticles have great potential for suppressing this disease, and they could be used very early on because as crowns are being planted, they could simply be soaked in some nanoparticle solutions before going into the ground. If there's any questions, you can certainly contact me at wade.elmer@ct.gov or my telephone number here, and I'd be glad to get back to you as soon as I can. Thank you.